This is Outlander Science Club, brought to you by Desiree Andrews, midwife, and Karen Doherty, emergency physician. Claire loves science, and so do we. Come with us as we investigate the science and medicine from the worlds of Outlander.
Hello, Outlander science fans. This is Karen, and this week we are talking all about seasickness. Jamie has at least 3 months ahead of him on stormy Atlantic seas, and it doesn't look good for him. With his history of severe seasickness, how is he going to survive? Well, let's start with what is seasickness. There is a quote from Hippocrates saying, "Sailing on the sea shows that motion disorders the body." So clearly something that humanity has known of probably since they started sailing. And we know it to be this unpleasant group of symptoms that happens in response to motion or to perceived motion. Now, it's generally thought that it occurs because of a mismatch between what the eyes see and what the body feels. So, for instance, you might be sitting inside an interior cabin of a ship. Everything appears to be stationary to the eye, but the body perceives movement. And this mismatch between the input of the vision and the input from the body is what is thought to cause these symptoms. Interestingly, you don't have to be moving to have this happen. It can also happen when you're looking at movement under a microscope. Say you're seated, you're stationary, you're not moving, but your eyes are looking into a microscope and seeing all sorts of movement on a slide, and that mismatch can also cause the same symptoms to arise. Or with virtual reality games, the same kind of situation where you are stationary, but your eyes are sensing movement. So we know the symptoms, they include dizziness, nausea, vomiting, increased salivation and sweating, generally feeling malaised, or an impending sense of doom. So the body receives input about its position and its motion in 3 primary ways. We use motion sense throughout the body in the muscles and the joints, and the little sensory receptors in the skin, the muscles, and the joints are sensitive to stretch and pressure, and they report that information back to the brain. So, for instance, you're standing on a ship, and it's gently moving back and forth, and you are sensing the movement that your body's making in response to these in order to stay upright. So, slight pressure on the ankle or on the foot as the surface underneath is tilting. And those inputs are sent back to the brain, where the brain processes that, okay, we're moving side to side here. Another input is from the visual system. The eyes send a report back to the brain about what we're seeing. Are we looking out at a horizon and seeing that we are moving in relationship to the horizon? So the brain processes the visual cues. And finally, the vestibular system. And these are structures in the inner ear, and they sense gravity, they sense linear movement, and they sense rotational movement. Inside small semicircular canals in the inner ear is a fluid called endolymph, and as the head rotates, this fluid moves within these canals and stimulates sensory receptors, which then send signals back to the brain that the brain then interprets as different movements and positions in space. So the brain receives all these signals from the eyes, from the muscles, the joints, the skin, and from the vestibular system in each ear, and the brain has to make sense of it. And motion sickness symptoms are thought to arise when the brain receives all of this input and it doesn't make sense. Interestingly, people who are blind can still have motion sickness. They have a functioning vestibular system in their ears, and they have the sensory receptors throughout their body sensing the position in their joints and their muscles and their skin. However, people who are deaf and thus lack the normal functioning vestibular system in their ear cannot have motion sickness. So it seems the vestibular system plays a pretty major role, but we don't quite know why. So why are some people more susceptible? It can be induced in all adults, pretty much. Anybody can be made to be motion sick with enough stimulation, but it seems to happen more so to particular groups of people. So children under 2 are typically resistant to motion sickness. The symptoms seem to peak at an age of around 12 and then decrease, though of course this is not the case for everyone. Women are more commonly affected, and pregnant women in particular are quite susceptible, which raises the question of the role hormones might play in the development of motion sickness. Migraine sufferers are also more susceptible. So once a person has motion sickness symptoms, they tend to improve with repeated exposure. So that after about 36 to 72 hours of continuous exposure, say on a ship, the symptoms typically tend to subside or resolve. Of course, not for everyone. If they do, then maybe say you're on a week-long cruise, you arrive and dock a week later, and coming back to the pre-exposure environment, returning to land, can cause your symptoms to recur. So what can we do for motion sickness? First of all, environmental modification. So people who are prone to motion sickness might get very ill riding in the car if someone else is driving, but they tend not to have the same trouble if they're the driver. Movements they generate themselves don't cause motion sickness. So I don't know if you have anyone in your life like that, but I tend to have to be the passenger in the car because my husband is prone to motion sickness, so he has to be the driver in order to avoid symptoms. Also, say you're on a ship and you don't have a lot of control over being the captain of the ship, theoretically, depending on your experience and the size of the ship, perhaps. But avoiding interior cabins, like we said before, having a visual cue of the movement is very helpful. So being up on the deck or looking out towards the horizon rather than sitting inside an interior cabin is helpful. And of course, we know there's medications for this. Antihistamines like Benadryl or Dramamine, or anticholinergic medications like scopolamine are helpful. They tend to be more helpful when taken before the symptoms start. They work better as preventative than a treatment. And scopolamine is available in a skin patch, which is pretty handy also. But of course, these don't come without side effects. Other medications that have been used include certain nausea medications, sometimes in combination with caffeine. We don't know exactly why all of these work. It is thought that some medications that influence the neurotransmitter GABA work because GABA is thought to play a role in the development of motion sickness. It seems like there's probably still a lot of research to be done to determine the exact etiology of why this is happening and figure out better ways to prevent it. As far as herbal remedies, ginger has traditionally been used for nausea and has also been found to be effective for motion sickness. And when you look at the drugstore, you'll see a lot of different products which are based with ginger. A study of naval cadets actually found ginger to be beneficial when given as a pre-treatment to decrease the amount of seasickness in new recruits. It's thought to affect the motility in the stomach, and as well as the serotonin receptors in the brain. And just a side note, ginger does interact with other medications, and people who take blood thinners should definitely consult with a pharmacist or their doctor before taking ginger. Peppermint is also used to treat nausea, and it's thought to be an antispasmodic in the gastrointestinal tract. And black horehound is also a traditional remedy for motion sickness and nausea and vomiting. So these may have been among the medications that Claire brought from the apothecary. Other options: biofeedback and relaxation techniques. Biofeedback has been shown to be successful in some people. It turns out even pilots and astronauts are not immune to motion sickness, and NASA has used biofeedback and relaxation therapy successfully to get pilots back to work and to help astronauts mitigate the effect. It turns out most astronauts do experience motion sickness to some degree because of the extreme change in weightlessness and in their loss of gravity that influences motion sickness greatly. And then finally, and more applicable to our topic in Voyager, is acupuncture and acupressure. So, originating about over 4,000 years ago in China, acupuncture involves applying fine metal needles to particular areas of the body in order to maintain health and prevent and treat certain ailments. So a practitioner would do a thorough evaluation and then insert thin needles into precisely defined points along the main channels of the body. And there's thought to be 14 main meridians or channels throughout the body associated with different organs. And acupressure is similar in principle, but it involves applying pressure to specific points along the body rather than needles. And it is known that the P6 acupuncture point, which is located in the inner wrist, just above, a couple centimeters above the wrist, has been studied extensively and is thought to be very effective for reducing nausea and vomiting. And this is the point that the acupressure wristbands work on. And you wear the wristband which applies pressure to this P6 acupressure point. So Jamie is found finally having his sense of humor back. So we know he's feeling better. And Marsley is in shock at the sight of him. He has needles behind his ears. He has needles in his wrists. He has needles in his legs. So let's take a look at those. And he has needles in his wrist in the very characteristic point that we know of for treating nausea and vomiting, in this P6 point. He also has needles in his lower leg. In his inner lower leg, about 3 centimeters above the ankle, is another point that is said to help with digestive symptoms and dizziness. And behind the ears, there are numerous acupuncture points along the scalp. But one in particular might be the one where Jamie is having some relief, and that's on the head just above the ear, gallbladder point, GB8. It's known to be helpful for ceaseless vomiting, so perhaps this is where Mr. Willoughby has applied those needles. And Jamie seems to have success. He is making jokes again. He's feeling better. He has been able to not vomit, he says, for the last 15 minutes, so things are looking up for him. How does acupuncture work? Well, in Chinese medicine, it's thought that there is a universal life energy called qi in every living being. And this energy travels throughout the body along specific pathways, these meridians. And health is maintained when the energy flows freely throughout them. But if the energy flow is blocked and this is disrupted, then pain and dysfunction can occur. And acupuncture is thought to restore normal function by stimulating certain points along these meridians to free up the energy. Now, Western medicine has also adopted acupuncture. It was mostly unknown in the United States until the 70s, and the story goes that when President Nixon's Secretary of State Henry Kissinger traveled to China in 1972, he was accompanied by a journalist named James Reston. And Reston developed appendicitis while he was in China and required an emergency appendectomy. And he reportedly remained awake during the operation, and his pain and anesthesia was all through acupuncture. So word spread, and U.S. physicians began studying acupuncture for its use in pain control, and soon found that it worked for other applications as well. So in Western medicine, the theory is that pain relief is due to the release of endorphins that occur when the needles penetrate the skin. And it's thought that acupuncture affects gastrointestinal disorders, perhaps by affecting the parasympathetic and sympathetic nervous systems, the nervous pathways which control gastrointestinal function. Some studies involving neuroimaging of the brain revealed that acupuncture has effects by activating and deactivating different areas of the brain in response to acupuncture at other points in the body. And the National Institute of Health has funded research that showed that acupuncture is effective in treating migraines and arthritis and chronic pain. So we will likely see acupuncture become more widely used in the United States, particularly as we seek to find alternatives and ways to minimize the use of opiate medications. And it is pretty interesting to see that despite all of our advances in medicine, we still depend upon and find relief with the thousands-year-old remedies, like those to treat motion sickness in the form of acupuncture or acupressure or herbal remedies such as ginger. And it is eye-opening as we watch Voyager that we do see and recognize these treatments that Claire uses so often are still the same ones we're using today. Things change, but they still remain the same. So we hope you enjoyed this week's episode of Outlander Science Club. We love talking all things science and all things Outlander, of course. So you can find us on Twitter at OutlanderSci and on Facebook at Outlander Science Club. So until next time, when in doubt, ask yourself, what would Claire do? Thanks.